All right, now we're going to finish our absolute value area problem, or our absolute value integral problem. So as we said before, we cannot do absolute values. We have to break it up to things we can do. I can do 1 minus x squared. This is that downward facing black parabola here. Well, the absolute value is going to take those negative values and push them up. It's going to change them from negative values to positive values. So between 0 and 1, it is the exact same thing, the absolute value versus the original function. But between 1 and 2, I want to change the sign of it. So that's why instead of adding it, I'm going to subtract it. All right, so now, first, I'm going to go ahead and do just this first integral here. All right, so let's do it. So I want the integral from 0 to 1 of 1 minus x squared dx. All right. So first thing I have to do is integrate that, or take the antiderivative. The antiderivative of 1 is x, minus the antiderivative of x squared is x cubed over 3. And I'm going to evaluate that from 0 to 1. Which means then I'm going to plug 1 in for everything. 1 minus 1 cubed is 1 over 3. Minus, plug in 0 for everything. 0 minus 0 over 3. When I get that, I get 1 minus 1/3 is 2/3, minus 0 is 2/3. That is the area of my first half. So now let's go back up. Now I need to find the area of this, the area of my second half. Let's go with purple. So I need to do this one. So that's going to be the area from 1 to 2 of 1 minus x squared dx. So let me get some blank space. All right, so I want the area from 1 to 2 of 1 minus x squared dx. Well, it is the same antiderivative as before of x minus x cubed over 3, and now I'm going to evaluate it from 1 to 2. So remember, when we evaluate definite integrals, we plug in the top number, then we plug in the bottom number. So when I plug in the top number, I'm going to plug in 2. So I get 2 minus 8/3, because 2 cubed is 8, minus 1 minus 1/3. All right, to make it a little bit easier, I'm going to get a common denominator, and 2 is the same thing as 6/3 minus 8/3, minus bracket 3/3 minus 1/3. So simplify this down. 6 minus 8 is going to be a negative 2/3 minus, and I get 2/3. Well, negative 2/3 minus 2/3 is 4/3. Sorry, a negative 4/3. This is the area of my second half. So now I have to combine them. So going back up, the area I got from my first half was 2/3. So the area from my first half was 2/3 minus the area from my second half, which is negative 4/3. And notice the positive area, the area above the graph was positive. The area below the graph was negative. That's why I need to subtract it to make it above the x-axis. So this is really going to give me 2/3 plus 4/3. So by multiplying by that negative, I put it above the graph. It's now a positive area. It gives me 6/3 or 2. So the answer to my original problem, the integral from 0 to 2 of the absolute value of 1 minus x squared dx, is just 2. But we had to break it up because we cannot do it as is. Alrighty, if you have the notes, I'm going to skip the middle part just for 1 minute, the mean value theorem, and I'm going to go to the second fundamental theorem of calculus, and then we'll go back and finish up that. So the second fundamental theorem of calculus tells us that just like multiplication and division are opposite operations, and addition and subtraction are opposite operations, if you do one then the other, you get the original. The same thing is true for derivatives and integrals. So the derivative d dx of an integral from a to x of some function, I'm going to call it f of t dt, so those variables match up, that equals just your original function. So the derivative times the integral gives us the original. All right, so what do I mean by this? So I'm going to work through one problem the long way, and then I'm going to show you how quick and easy this really is. All right, so if I say find the derivative, so d dx, of the integral from 1 to x of t cubed dt. Notice what has to match up. The variable inside my integral is t, so that means I want to integrate with respect to t, so be aware of that. The variable outside x has to match up with my integral variable here of x. All right, so in math, we typically do what is inside the parentheses first. So I want to do the integral from 1 to x of t cubed dt. So integrate it. Add 1 to the exponent and divide by it. So t to the 4th over 4, I want to evaluate from 1 to x. Well, we've done this before now. You want to plug in the top value minus plug in the bottom value. So that's going to be x to the 4th over 4 plus 1/4. That's the integral. That is what is inside my brackets. So because that's what's inside my brackets, I still want to find the derivative of that. Well, in order to find the derivative of x to the 4th, you multiply by 4, reduce the exponent by 1, the denominator stays there. The derivative of a constant goes away. So I get just x cubed. The 4's cancel out. So here's the deal on this. The quick and easy way, if we go back to the original, just change your t to an x and you're done. That's it. It just changes by having this variable of x here. It changes my variable. So if you have an integral from 1 to x of something, you are just going to change your variable to an x and you are done. There is one small caveat. If the x is on the bottom and your constant's on the top, what does that do? That changes the order we subtract in. It would be the 1/4 minus x to the 4th over 4, which would make this negative at the end. So if 1 is on the bottom or any constant is on the bottom and x is on top, change your variable to an x and you're done. If x is on the bottom and the constant's on top, then it's negative in front of everything, change to an x. So if we do a couple of little ones of these are the quick and easy ones. So what is the derivative of the integral from 1 to x of the sine of t squared dt? Well, because it's just from 1 to x, I'm going to change my t to an x and be done. The sine of x squared. That is all I am looking for. That is absolutely it. So let's do one more quick one. The derivative of the integral from x to 0 of t times secant t dt. All right, so I'm going to change my t to an x, so I get x secant x. But because x is on the bottom of my integral symbol, it means I'm subtracting all of that, so I need to have a minus in front of all of it. That's it. We're done. That is the second fundamental theorem of calculus. So in this video, we finished up the first fundamental theorem of calculus and did all of the second fundamental theorem of calculus. In the next video, we will finish up, hopefully, section 4.4 and the mean value theorem for integrals.